In this video, we're going to be looking at Chapter 7 on voting systems. Now, this chapter relies on a voting system that not a lot of states use currently, but the state of Alaska recently used it in their Senate race. And it is a situation, this preference ballot situation, where you vote for your top 3 or top 4 votes in order of how you want them to go. So that's what this Chapter 7, Section 1 is about. And we're going to start with our definition of majority rule. So majority rule is when the person who receives more than 50% of the vote wins. Now, it's not just the most, but they have to receive more than 50%. More than 50% wins. So that's majority means more than 50%. Now, the type of ballots that we're going to look at in this section are called preference ballots. And a preference ballots are ballots in which the voters can choose not only their favorite candidate, but they actually order all of the candidates from their most favorite down to their least favorite. Right. So I hope you can actually read that. It's ballots in which voters choose not only their favorite candidate, but actually order all of the candidates from their most favorite down to their least favorite. Now, most preference ballots are transitive, meaning that if you voted for A, C, B, and then D, but C dropped out, then the new order would be A, B, D. Everybody just moves up a position. That's what it means for the ballots to be transitive. Now we're going to look at an example of preference ballots here as we look at this election where you're voting on your favorite candy. So here you were given a preference ballot where they had you evaluate Crunch bars versus miniatures versus Snickers. And here is how people voted. So Anna voted for Crunch, Snickers, and then miniatures. Bob voted for M, S, and then C. This is their first, second, third choice, all the way down to Riley here. So we need to organize this data. And when we organize the data, we call it a preference schedule. So a preference schedule is a table that we use to organize the results of all the preference ballots in an election. So here, you see up here where it says Anne voted for C, S, and M. So that order, we count how many people chose also C, S, and M. So Annie chose that. CMS. Okay, so Annie's the only one. If we go down, this is what a preference schedule looks like. So I'm going to reduce this a little bit so we can see how it was organized. I think you're actually going to be asked to do this on your homework. So if I look at this first thing, this first column here, it says that 3 people voted for miniatures first, French bar second, and Snickers third. We could find those here. So MCS, that's here, Dylan. And looks like JC. And it looks like Lamb. So if you look at all the rest, those are the only 3, and that's reflected in that across the top. We count how many people had that order. And then MSC here was Bob. But if I look, there are no other MSCs if you look through the table, so there was only one of those. So if we added all these numbers across the top of the table, it would tell us how many voters voted in the election. So 3 plus 1 is 4, plus 4 is 8, 9, and 9 is 18. Looks like we had 18 voters in the election. And you can go and check it here. The most prevalent choice was SMC, which happened here 1, 2, 3, 4, 5, 6, 7, 8, 9 times, which is reflected in the 9 at the top. So that's how a preference schedule works. Let's keep rolling. So in the method of counting ballots, if you were going, there are several methods. There's the plurality method here. There's the board count, which is the point system. There will be a plurality with elimination. And then there will also be pairwise comparisons. So there are 4 different ways that we can choose to elect a winner with preference ballots. The first way is plurality method, which just says the candidate with the most first place votes win the election, meaning they don't have to have a majority, just the most first place votes. Again, they just have to have the most first place votes, not necessarily a majority, which means they don't need to have more than 50%. So if we look at our Candy Crush election, it appears here that M had 3 first place votes in this column, and in this column had 1 more. So totally M miniatures had 4, 3 plus 1 or 4 first place votes. If we look at C, it had 4 plus 1 or 5 first place votes. And it appears that Snickers had these 2 columns, so that's 9. So who wins by plurality? That would be S for Snickers, wins by plurality. Now, do they have a majority? They only have 9, and 9 is not more. It is 50%, but it's not more than 50%. So Snickers won by plurality, but not by majority. The next method we're going to look at is board count method, and it is a little bit complex. It's not complex. It's got a little more involved. So in board count, each place on the preference ballot is assigned points. The last place gets 1 point. Next to last place gets 2 points, et cetera, et cetera. So that if there are n candidates, each will receive n points for the first place on each ballot, and then 1 less for the second and 1 less for the third. In the end, we tally up the points, and that determines who won by board count. It's difficult to look at the definition in this form, but as we go through an example, that will help explain what it means. So go ahead, pause the video, take this down, and then we'll go on to our next example. So as we look at this, I recopied the preference schedule down here to do the board count method with our values here. Now, the third choice, there are 3 choices. So the third choice will get 1 point for each vote in third place. Second place will get 2 points. And first place will get 3 points because you get the most points for being in first place. So if I look at M here, he's going to get 3 points for each vote he got, but he got 3 votes. So 3 times 3 is 9. And then if I go and continue assigning 3 points for each vote received, then in this column, M would get 3 times 1 or 3. Here, C, Crunch Bar, had 4 first place votes. For each of those votes, they're going to get 3 points. So 4 times 3 is 12. And then here we'd have C getting 1 vote. So he'll get 3 points for that vote. If we look at Snickers bar here, they had 9 first place votes. So they're going to get 3 points for each one of those. And 3 times 9 is 27. And here's 0. We don't even need this column. So continuing on, for the second choice, each letter or each choice will get 2 points. So here, this was Crunch Bar. It's going to get 2 points for each time, and it got 3 votes. So 2 times 3 is 6, and so on. 2 times 1 is 2. Here, 2 times 4 is 8. And here, 2 times 1 is 2. And for M here, 2 times 9 is 18. In our last bar, each candidate, if you will get 1 point for each vote they receive. So S is going to get 3, C will get 1. S here will get 4. C will get 1. And here C will get, or M will get 1. And here C will get 9. Now we just total up these points. So for miniatures, we're going to total up, let's see, wherever it occurs. So here we have 9 plus 3. And then here we have 8 plus 18. And here we have 1. So if we add that up, we get 2739, I believe. Might want to grab your calculator for these. So I'm actually going to ask you to go ahead and find the board accounts for Crunch bars and Snickers. Pause the video, give it a try, and let's see who won this race. When you complete the total with board count, it looks like miniatures are our winner. Now, this next method is called plurality with elimination. And there is a video on this. I'm going to post a link to it right now. So in Alaska, they call it a ranked choice voting system. It is the same as our book's plurality with elimination method. If you want, the video is really good. It gives a nice visual representation of what happens. But just to describe it, what happens in plurality with elimination is if there are no candidates with a majority, then you eliminate the candidate with the fewest first place votes and redistribute their vote amongst the other candidates. You repeat this process until you find a winner. Now, at any time during this process, if a candidate has a majority, so more than 50% of the first place votes, then that candidate is the winner. Go ahead and pause the video if you need to get that down. The way this works in our candy election is we look at our preference schedule and decide who has the fewest first place votes. So we look at this column across the top. It's not gonna work there, okay? It looks like M here has both 3 and 1 first place votes. So M has 4 first place votes. Looks like C has 4 plus 1, or 5 first place votes. And Stickers has the 9 first place votes. So candidate M, which was miniatures, who won by plurality, they have the fewest first place votes, just 4. So wherever we see an M, we mark them off. So M just got eliminated because he had the fewest first place votes. But what happens there is in my first column that had 3 votes, C and S move up. That happened here. S and C move up to first and second place in the second column. C and then S moves up in the third column, and so on and so on. So now we count and see who has the majority. It looks like if we count first place votes, it looks like C has 3 plus 4 plus 1, or 8. That would be C. And then it looks like S has the 1 here plus the 9. So it's like S has 10 first place votes. And that is majority because 9 would be half. There were 18 voters, as I recall. S has a majority. So who won by majority? And that would be S for Snickers. All right, the last method that we're going to look at for counting votes is called the method of pairwise comparison. Let's get this down. So the method of pairwise comparisons is where we compare each candidate to each of the other candidates in one-on-one matchups. We give the winner of each pairwise comparison 1 point, and the candidate with the most points wins. Interesting. So we're going to pair up each of the candidates and give the winner of each pair up a point. Show you how that works. Here there are 3 candidates, M, C, and S. When I do these, I kind of like to draw them as a polygon. M, in this case, a triangle, C, and S. So we'll pair these guys and see who wins, these two, and see who wins, and these two, and see who wins. So if we start with S and comparing S to M, we go and we see who won in each column. So in my first column here that had 3 votes, M was in first place and S was in third place. So in this comparison, M won and gets those 3 votes. Put that under M. In my second column that had only 1 person choose it, M was ahead here also. M was above S, so M gets 1 point. In my third column, again, M is above S, so M gets these 4 points from that column. In my fourth column, S is second and M is third, so S gets the 1 point here. And in my fifth column, S is in first and M is in second, so M won and gets those 9 points. So if we add these up, S gets 10 points and M gets 8 points. So S won. So in my tally for points, S has 1 point. Now let's compare M to C. And we do the same thing. We look in our first column, M is first and C is second. So M gets those 3 points. In my second column, M is first and C is third. So M gets that point. In my fourth column, C is first and M is second. So C gets those 4 points, et cetera, et cetera. Here, C is going to get the 1 point. In my last column, M is ahead of C. So M gets all 9 of those points. So in this case, it looks like C won. C was ahead of M 5 times, but M was ahead of C 13 times. So M won that round. So M gets a point for winning that round. Now, if they tie, they both get half a point. And you may see an occasion where they tie. But let's go ahead and compare now S to C. Here, S to C. In my first column, C is second and S is third. So C gets those 3 points. In my second column, S gets 1. This is 3. In my third column, C is ahead of S, so C gets those 4 points. My fourth column, C is ahead of S, so C gets that 1 point. But in my fifth column, S is ahead of C and gets all of those 9 points. So here S had 10 and C had 8, so S won. So S won twice, C won once, or I'm sorry, M won once, and C won 0 times. So Snickers is the winner using pairwise comparisons. All right, in our next video, we are going to look at more applications of these voting methods and counting methods. All right, thanks for watching.